29 questions, you can see a heavy dose of quadrilaterals on there. All right, heavy dose. Guys, I was going to do this today. I was going to be like, all right, write the word parallelogram. Everyone, what's the parallelogram properties? And write them all down. Let's go to rectangle and write them all down. That was like such a waste of time. And you guys have it in your packet. If you go to the start of Unit 6, all the properties are labeled there in a flow chart. So it's a waste of time. So today it's, all right, let's quickly review some of the properties and then let's do some algebra with them. All right, let's go hardcore. So first one here, I need you guys help me to fill out the table. We're going to put an X in any of these quadrilaterals that apply to the property on the left. So let's see if we remember here. Both pairs of opposite sides are congruent. Both pairs, opposite sides congruent. Is that a parallelogram? That is, yes. Now look, let's make this easy on ourselves. If you're telling me that's a property of a parallelogram, it's a property of the rest of the family, which include rectangle, rhombus, square. Okay, if it's a property of a parallelogram, it's a property of the family, the rest of the family. Trapezoid? Trapezoid? Yes, no? No. Isosceles trapezoid. Both pairs of opposite sides congruent. Nope. How about a kite? No. Two pairs of adjacent sides are, but not opposite sides in a kite. Two pairs of adjacent sides are. All right, diagonals congruent. Parallelogram. Diagonals congruent. Going. That's a big no. How about in a rectangle? Diagonals congruent in a rectangle. Is that yes or no there? Yeah, that's true. Rhombus? Nope. Square? Yeah, if you put any X in for parallelogram, rectangle, rhombus, the square is going to have it too, because the square has everything in the parallelogram family. Trapezoid? No. Isosceles trapezoid? That's a yes, ladies and gentlemen. That is a yes. Diagonals in an isosceles trapezoid are indeed congruent. That's why we review. How about a kite? Congruent in a kite? No, they are not. All right, what about perpendicular? Parallelogram? No. Rectangle? Perpendicular? Diagonals? Rectangle? No, they're congruent. Rhombus? Yeah, they're perpendicular in a rhombus. Square? Absolutely, if they are in a rhombus. Trapezoid? Nope. Isosceles trapezoid? Just congruent. Just congruent. How about my kite? Diagonals perpendicular in a kite. Yes, diagonals are perpendicular in a kite. Bisect each other. Parallelogram. Diagonals bisect each other in a parallelogram. Come on. Yes. So that means they bisect each other in all the rest of the parallelogram family. They bisect each other in a trapezoid. No love for the trapezoid yet, huh? Isosceles trapezoid? No, they're just congruent. Remember, that is it. Just congruent. Kite bisect each other. Let's talk. Not each other, but one gets bisected. Which one? Longer bisects the shorter in a kite. Longer bisects the shorter. So keep that in mind. They don't bisect each other, but one does get bisected in a kite. So that's done. Consecutive angles, supplementary, parallelogram. Yep, which means the rest of the fam's going to get a little love there. How about in a trapezoid? No, but let's talk. So we're good with the trapezoid. Here you go. Here's my trapezoid. Remember, in a trapezoid, one pair of opposite sides are parallel. Now, I have angles 1, 2, 3, and 4. Not all the consecutive angles are supplementary, but some of them are. 1 and 2 are. 4 and 3. Why? If these lines are parallel, what do we call those angles 1 and 2 and 4 and 3? These are same side interior. So I'm not going to put an X there, but realize there are certain consecutive angles that are supplementary in a trapezoid. All right, but not all of them. Like 2 and 3 aren't, 1 and 4 aren't. So isosceles trapezoid would be a no, and so is a kite. The consecutive angles are not. All right, finally, both pair of opposite angles congruent. Parallelogram, is that a property of a parallelogram? Both pairs of opposite angles congruent? Yep. So rest of the family. Trapezoid? Nope. Isosceles trapezoid? Nope. Kite? Kite? No. No for that word right there. Both, but talk to me here. There is one pair of opposite angles. Where are they? Not both pair, but there is one pair of opposite angles that are congruent in a kite. That's what I was thinking too, right there. Where the non-congruent sides intersect. Those are the angles that are congruent. Not both pair though. All right, we good? All right, one more of this whole property stuff before we apply it. Name that quadrilateral. I'll list a property. You name all the quadrilaterals that apply. And yes, you will fill in all the blanks. Both pairs of opposite sides are parallel. What am I talking about? Nate, give me a figure that I can write down. Here we go. Great job, everybody.
Square.
Maybe I should go back to the numbers, huh? Square. Yep. Rectangle. Oh, look at you guys. What else do I have? Rhombus. So you're basically telling me all of the parallelograms. Yes, that applies to all of the parallelograms. Opposite sides congruent. Well, we just went over that in the chart, right? That's all the parallelograms again. And both pairs of opposite angles congruent. Also, all the parallelograms. Oh, that's going to change now, though, kids. Exactly one pair of opposite sides is parallel. Not both, exactly one. Zeev, trapezoid. I got another blank up here, though. If trapezoid is the isosceles trapezoid will be as well. Good work. And finally, exactly one pair of opposite angles is congruent. I know we mentioned it already, but it's the kite. We good? Questions? All right, now we're going to apply it. Break out that calculator. Let's roll, kids. Here's my first question. It's a rhombus. Find side AB. It is a rhombus. Find side AB. So now here's how we approach this. We label our diagram, put as many markings on as we can because we know our properties of a rhombus. All right, we mark as much stuff as we can that hopefully we'll say, oh, now with all these markings, this will lead me to how to find AB. All right, it's a rhombus. What do you want me to add to the diagram here? I know one diagonal is 10, the other diagonal is 14, and we're looking for a side AB. Rhombus. It's a rhombus. This is what's going to happen on the midterm. You got to use your properties to find a side or an angle. Anybody marking their diagram with anything that I can mark my diagram with? Because you know properties of a rhombus. Right angle, diagonals are perpendicular. I'll put a right angle up here. Good. All right, more. Zeev. They bisect each other. Good start. So diagonal AD is getting bisected. So on AM, I can put 5, and MD, I can put 5. Same thing with the other diagonal. BC is 14. So CM is 7, BM is 7. You have just used your properties of a rhombus to help you out. Now look at your diagram. What's going to get you to X? And you have this, by the way. This is one that'll be given to you. You don't need to memorize this one. Jonna, Pythagorean theorem. Good work. Yep. Two sides of a right triangle. Use Pythag to find the third. Where's the 5 and the 7 going to go? A, B, C? 5 and the 7, where do I put it in the formula? A and B. Those are the legs. C is the hypotenuse, which we're trying to find. So 5 squared, 7 squared, C squared. I've been assuming this incorrectly, where we go from here. So let's just make sure we're solid, because I see different things from different students, believe it or not. You can't take square roots here yet. Okay, you got to go 25 and 49. You still can't take the square root. You have to add first. You have to add those two together. 74. All right, now once you're down to this point, you take the square root. We don't square root yet until the end. And you go to your calculator, you do square root of 74. It can't break down because your calculator gives you back square root of 74. All right, can't be simplified anymore. So that's how we leave it, square root of 74. Applying your properties to solve a problem. Next, stick with the rhombus. Find my missing angle BCA. It's okay if you cannot find the angle right away in one step. Start filling in the diagram, all right, with as much information as you know is true. It's a rhombus. Start going through the properties in your mind. Where else can I put degree measures? It might not be angle X, right? But you'll get there. You'll get there. And the good news is there's multiple ways to get there, right? You and everyone else in your group might be doing different ways, but you'll all get to angle X. All right, what's everyone doing here what are you throwing on the diagram? Getting excited about this one. What can I put on the diagram that's going to help me get to X sooner or later? Matt? The perpendicular. I can throw right. I got right triangles up in here. Yep, all those are right angles. All right, I'm getting there. Aiden, what's good?
Alternate interior.
Oh, yeah, remember, opposite sides parallel, so alternate interior angles are congruent. So if that's X, that could be X, or if you put 70 here, that could be 70, right? And now I look at it and say, whoa, this is an easy problem now. Because I have a triangle where I know 2 out of 3 angles. 180 minus 70 minus 90. $20. Can I also mention another property that we did not go over yet today of a rhombus that could have helped you here as well? We did not go over the diagonals bisect the angles of a rhombus, right? So if that's 70, that could have been 70. If that's X, and we could have done the same thing using that property. Okay, so the diagonals bisect the angles in a rhombus and a square. Hey, we all good before we go on to the next figure? All right, warning about this one. You are taking an honors midterm, not a regular geometry midterm, an honors one. So out of those 29 questions, maybe 1 or 2 might stump you. You might look at it a little bit longer than the other questions. Welcome to number 7. All right, I just want you guys in the mode. All of these aren't going to be very easy, and you're going to blast through them. Some of them are going to be tough on the midterm, and you're going to have to stop and think for a little extra time, which is this one right here. Angle POM. It's an isosceles trapezoid. So in my mind, I know NO is parallel to MP. And since it's isosceles, the legs MN and OP are congruent, those 2 legs. And I need you guys to get me to angle POM somehow. All right, start filling out what you're confident in. There might be a few tough ones on that midterm. You got to stop and think and don't give up. Is anybody, what are you guys labeling your diagram with here? So I can match you guys. What else do you know is true? Any other angles you're going to find? Nothing else. We're just going to stick with those. Any other angles you know are true? Does it say isosceles trapezoid? Got to put angle measures somewhere. Okay. We'll just leave 28 and 42, I guess. I'm not doing this one for you. Refuse to do it. How do I get to POM? Don't start making up stuff because you get desperate either. Don't pull that. Don't start making up stuff because you're desperate. Okay, you want to direct me anywhere here? See anything? I just want you to feel what it's going to feel like, might feel like on Tuesday at some point in the midterm. Or you think you're stuck, but you know more than you think you do. Any plans out there? Any plans? Think you got something, Zeke?
Angle PNO is 28 because parallel lines alternate interior.
Oh, okay. So you're going this one right here?
Yeah.
Yeah, I'll agree with that. Absolutely. That's 28. That's an alternate interior angle. Yep.
Then angle PON is 110 because it was 42 in the corner of the triangle there. And the angle's at 180.
Okay, so you're taking, so just so I'm clear, you're taking triangle NOP right now, right? Triangle NOP, where I know 28 and 42, subtracting them from 180, and you're getting 110. Okay, good. All the other, I don't know if anybody did it. This adds up to 70. These are same side interior, so they have to be supplementary. So, yep, that's 110. And then from there,
And then,
okay, good job so far.
Where'd you get?
Anybody else want to kickstart Right. Go from where Z left off. Okay, you ready then? Because this is the level you got to be at. Think outside the box a little bit sometimes. Everyone take a look at triangle NMP. Oh, go ahead, Matt.
Is that like, are those isosceles, like the smaller triangle? One with 28 in it?
This one here?
Yeah.
It's going to be in a second. But you got to show me why, right? You can't just assume that. It's going to be isosceles in a second. Here you go, kids. Let's see. I'll go. What color am I going to use? Blue. Take a look at triangle OMP. This one right here. And the one that it overlaps with, which is triangle NMP. You want to tell me anything about those two? They are congruent. Side, side, side. Legs congruent, reflexive, diagonals congruent in a isosceles trapezoid. Or you could go side, base angles equal, reflexive, side, angle, side. Why is that great to know that they're congruent? If this angle's 28, so is the angle it corresponds to, CPCTC. And now look at triangle OMP. How many angles do you now know in triangle OMP? 2. The big one, angle P, and we just found that that was 28. So angle POM, 180 minus 28 minus those two added up, which was 70. And that's how we get our final answer of 82. Gonna think, guys. Gonna think on a couple. I'm guaranteeing it. All right. Do not give up. Take another. Maybe go back to it so you get a fresh mind. All right. If you want to skip over it, go back to it. All right, and start thinking a little bit outside now. Questions there? We had to use congruent triangles on a trapezoid problem. All right, 11. I will be totally honest with everybody. The only reason I signed 11, read carefully. This problem, I think, was on the quad quiz I gave you guys this year, the quadrilateral quiz or test, I can't remember. And here's what happened. Everyone marked the diagram beautifully. AF and FD. You said that was isosceles, so you gave me those two were congruent. And then I asked for angle AFD, and I got a handful of you gave me that angle. ADF. Read. And you know what? That answer's here somewhere because I want you to pick it. Fall into my trap. Read the darn question carefully. I'm looking for AF. D, that one up top. That one up top. I have more than enough confidence that you guys can get to it. Just find the correct angle. All right, if this is 124 and it's a parallelogram, opposite angles are congruent. So that one's going to be 124. I got a linear pair up in here, so they're supplementary. So the angle supplementary to it will be 56. So will angle A, because in a triangle, congruent angles are across from congruent sides. And then you guys are on your way to find the actual answer, AFD. Which was what, 68?
Yeah.
So just read the darn thing carefully, please, kids. Read it carefully for me. I'd really appreciate it. All right, anything so far? All right, how about give a little love to the kite? You never know what he's going to throw on there. Anything is fair game from the 7 units. All right, notice I didn't ask for angle 2. I'm not concerned with it. If you want to find it, go ahead, but I'm not asking for angle 2. So angle 1 and angle 3. Now I'm going to start with angle 3. Let's find angle 3 first, because I think that might be a little easier. What do we know about those diagonals? Perpendicular, short, longer bisects the shorter, but for our case, we want to know that they're perpendicular. So for angle 3, 180 minus the two angles we already know, 90 and 39. $51 degrees. All right, how are we getting to angle 1? How are we getting to angle 1? We just found that was 51. Go ahead, Doyle.
You can do the big triangle DAB, because DA is comparing to AB as an isosceles triangle.
Everyone hear what he just said there? That's isosceles, DAB. So keep going.
Angle 3 is congruent to ABD. And then angle 2 is a right angle.
Yep.
So then just 180 minus 90 minus 51.
There you go. And that gives you 39, I believe. Did anybody figure out why that these two are the 39 I gave you and angle 1 would have been congruent? In?
Side angle side.
The triangles are congruent by side angle side, HL, side side side, a lot of reasons. So CPCTC would have said the 39 and angle 1 would have been congruent. Ian?
So Doyle said there was an isosceles triangle, and that's why you knew it was 51.
Triangle ADB is isosceles.
Yeah.
Yep.
But I thought you said like the angles bisect each other. So when
The angles bisect.
like the
Okay.
diagonal.
Okay. Oh, yes. Are you think the diagonals
Well,
we said in a kite, one pair of opposite angles were congruent.
yeah. Isn't it not those angles?
It's angle ADB with angle ABC. Not the partial angles, the full angles are congruent.
And DB doesn't bisect them.
Let's see. Would they bisect? I'm trying to think. Do they bisect the angle? Well, yeah, they would, because these are already would be congruent by CPCTC, and see these two triangles down below are also congruent. So these are equal by CPCTC, and then you do addition. So yeah, they do bisect.
But they only bisect in like.
Well, no. Oh, I shouldn't say. Well, I guess they would have to bisect each other, right? 51 and 51, and those two are got to be, so those two below have to be equal. Well, no, I wouldn't say the word. I don't like the word bisect though, because bisects means if that's 51, that's 51, which is incorrect. Like this could be 100, and that could be 100. So they don't bisect it, no. But these two on top are equal, and these two on the bottom are, but they don't bisect the angle because those two would have to be equal. Okay. Anything else? Okay. Doesn't have anything to do with quadrilaterals. Just throw a review one at you. Why not? Keep you on your toes. Just throw a review. How do I get to angle ADE? I know there's a lot of triangles in that diagram. I know there's a lot of triangles, but guess what? No matter which one you look at, the interior angles all add up to 180. All right, doesn't matter the size of it, as long as it's a triangle, interior angles add up to 180. How's it look? I'll just do my approach. Some of you may found more angles than I did. I looked at the big triangle, ABE, because I already knew that was 90, and I knew angle A was 45 degrees. So I said, all right, angle E must also be 45 degrees if all three of those angles have to add to 180. And then I said, all right, now I have triangle ACD. Now I have triangle AED, triangle AED. I know 2 angles, add them together, subtract them from 180. No matter if you did it my way or found more angles, 120 degrees for angle AED, 120. 120. Any issues there? Getting 120, you did it a different way. Way to go. High five. Sure, Matt.
Are those angles congruent? Like where B is? How that symbol is?
No, that's a right angle symbol.
Uh,
Yeah, those aren't arc marks. That's a right angle symbol. Okay.
wait, how do you know bottom right was 45?
Okay, triangle ABE, that's a right angle, 90.
Oh, okay, yeah. Right.
Add those two together. I got 45. So I have 45 degrees left. Everyone else is all right? Okay. For tonight, I'm going to leave you with this last one to see what you can do. Finding the perimeter of T. This is one where you're going to have to think outside the box a little bit. Okay, one of those stumpers that you might come across on the midterm, and some practice out of your midterm review packet. Let me get you those pages and numbers I'm suggesting. Pages 48 to 52, numbers 16 through 28 even. That is what I'm suggesting for tonight's practice. All right, 16 through 28 even on pages. They're all quadrilateral questions. All right, they're all quad questions. So see if anybody can tackle this last one. It's a stumper.